Well, anyway, nerds, we're back at it. It's been a while since you guys were the nerds. Yeah? In a week or two? I know, you missed it. Anyway, Algebra 1 stuff, solving systems of equations algebraically. Today we are solving by substitution. That's it. We're going to do the front of these notes. It's these 4 examples, nice, quick lesson, and then you'll spend the rest of the period working on the homework. Yeah? Not too bad. Okay. So it says solve the system of equations by substitution. We could graph. We're not going to. I don't want to graph anymore. Graphing is not accurate enough. It's a pain in the butt, right? Instead, we're going to substitute. And the way we do that is figure out what one of the variables equals and plug that stuff into the other variable. For example, if I said, hey guys, x is 3, you could plug in x there or there, and you could get y by itself, right? You could solve for y. All right, well, what we're going to do is we're going to figure out what one of our 2 variables is, whichever one's easier, and then plug that expression in to the other equation. So looking at the top equation and the bottom equation, one of them has a variable that will be very easy to get by itself. Which one is it, top or bottom? And for the top one, what variable would you get by itself? You could get y by itself by dividing by 4. But that's going to give you a fraction here. Is that wrong? No, it's 100% fine. You could do that. But I also know that most of my people don't like fractions. So what I would say is, if you come down here, there's not going to be any fractions involved if you get this y by itself. Absolutely nothing wrong with getting that y by itself and using it and plugging it in right there. Works just fine. It's just that it's a little more work. We can get this y alone, though. And if we knew what this y was, when we know what this y is, we can plug it in up top. So I'm going to start getting that y alone. Tell you what I'm not going to do, though. I'm not going to subtract 2x and divide by -1. Because I still have a bunch of people forgetting that when they divide by -1, it flips an inequality symbol over. This is not an inequality, but I have a bunch of people forgetting that that happens, and it's probably because they don't remember why it's happening, like I showed you. So rather than trying to remember, because I am also trying to review the test that we took yesterday, rather than trying to remember that rule, what I'm going to do is get this y by itself and make it positive without division. So I'm just going to add y to both sides. And now it'll be positive. It won't be alone, you say. Fine. Subtract 10. Now it'll be alone. So that secondary equation down there will now be 2x minus 10 is what y equals. And like I said, if I told you the value for y, you could just plug it in. Well, this is no different. It's not a value for y, it's an expression for y, but you can plug it in. So take what we know y to equal and replace y with what it equals. It's like a composition of functions like we did in Unit 1. We're going to plug it in right there. Right there. The paper doesn't want to write. Not my paper, my pen. There we go. It'll work better now. There we go. So in this top equation, I'm going to write 4, a set of parentheses that we're going to replace with whatever y equaled in a moment, and 6x minus 16. And what we found y to be was 2x minus 10. Got the orange and blue going for Go Gators. Okay. Distribute your 4. I don't know if I need to show this work, but distribute the 4. X minus 40 equals 6x minus 16. Good old Algebra 1. Let's get all our x's. Since there's no exponents, get all our x's on one side and everything that doesn't have an x on the other side. I don't want to have to divide by negatives if I can avoid it. So I'll bring 6x to the left. And I will add 40 to both sides. What does it give me? 2x equals 24. And divide by 2. Yay! Easy review. When you say you mean use elimination?
Yeah.
We'd have to manipulate it a little bit, to make things match up.
Yeah, yeah.
But that's what we're doing on the back.
Oh.
That's what we're doing tomorrow. Here's the good news. On the test, I'm not going to say solve by substitution. I'm not going to say solve by elimination. I'm just going to say solve the system. Because I honestly don't care which method you're good at. Just be good at a method. Like for factoring, I just tell people, like, I don't care what method for factoring you use. Just be good at it. Pick one you like, stick to it, be good at it. Boom. So solving systems of equations, you could use substitution or elimination. I can't imagine anybody would want to use graphing. But you could use substitution or elimination, whatever you want. Whichever you choose. I'm going to do the substitution on here. But especially because for questions like this word problem at the bottom, you want to use substitution. I mean, you don't have to. You could use elimination. But I feel like it's easier with substitution. Now that I know what x is, though, time to find y. Just by taking this. Oh my gosh, the phone's ringing. All day. Oh my gosh. I forgot what I was saying. But anyway, we're going to take this x and we're going to plug it in. Well, really? It's like a comedy. She called me right back. Oh, God, you can't make that up. You can't make that up. Anyway, eventually I'm going to plug x equals 12 into this thing. Right here. It's going right there. It's right here. It's right here. All right, so we go y equals 2 times whatever x is minus 10. Good gravy. We'll get there eventually. What is it? 12. Yeah. So y is 24 minus 10, which is 14. Remember when we were solving by graphing? These are two straight lines. And if we find a solution, that is a point in space where the two straight lines intersect. So we have found out that these two straight lines intersect each other at 12, 14. That is your answer. And you could graph them if you wanted to. It'll work. But no need. Substitution. Questions for me? Talk to me, guys. Is it just that easy? You remember how to do it that well? Yeah? Okay. I try to avoid fractions if I can. So basically, if substitution is going to cause me to work with fractions, I typically won't bother and I go directly to elimination. That's pretty much how I work. Yes, Parker.
Is there like a certain equation that we have to choose for of the two to plug the x in?
No, you could have plugged x into either one of them and it would have worked. So if we had put 12 right here, we'd have gotten 72 minus 16, which is 56. And 56 divided by 4 would have given us the 14. Yep. The only thing that you have to be careful about when you're plugging things in is right here. When we got this y by itself, you can't take this 2x minus 10 and plug it in to the equation that we got it from. If you do that, you'll get 0 equals 0. Other than that, plug in anything you want, anywhere you want. Next. Yes? I don't know if you noticed, but this equation is the same as it was right here. So I'm not going to show that math again. I'm just going to go directly to y equals 2x minus 10 because we got that result from above. And then we're going to utilize it in the exact same way we did in the question up above. But instead of being 4y, it says 3y. And instead of saying minus 16, it says minus 15. Wash, rinse, repeat. Exact same thing we did on the last one. Distribute. 3 times 2x gives me 6x. 3 times negative 10 gives me negative 30. And just like before, there's no exponents. So let's get all our x's to one side. I'll move mine left because why not? And when I do that, what it's going to give me is negative 30 equals negative 15. From before. Is this a true statement? Oh, this is a false statement. So what does that tell us? There's going to be no solutions. Recapping from the test, what's the only way that two lines will have no solutions? If they're parallel. But what's necessary in order for two lines to be parallel? Same slope and different y-intercepts. Okay. Do you know why I'm reviewing that? Because the question that asked you about linear line, in sentences, the linear equations, about how many solutions they have, it was the second most missed question on the test. Over half of my students missed that question. solving a system. This time, that bottom equation is different. But we can get y alone after a single step. We're just going to subtract the 2x from both sides. And that will give me at y equals, and there's no reason to even change its order. I'll even just say 10 minus 2x, whatever. If you want to say negative 2x plus 10, you can. It doesn't make a difference. It's not a big deal. But we're going to do the same thing we did for the last two examples, is take the expression for y, and we're going to drop it in right there. Kind of tired of writing in blue, though. I'm going to write in purple and green for this one. And distribute. 4 times 10 is 40. 4 times negative 2x is negative 8x equals negative 8x plus 40. Check that out. Look, if you decided to get all the x's on one side, look what you would get. You get 40 equals 40. This is an absolutely true statement. So what does that tell us? How many solutions are there? Infinite solutions. Now, what we don't want to say all real numbers. I mean, that's true for x. Yes, it's true for all real values of x. But because we're talking about two lines intersecting, we're talking about pairs, x, y coordinates. So we want to say there's an infinite number of x, y solutions that work. And the part we've all been waiting for. Word problems. This is not going to be any different than the word problems that we had on the previous homework. I think it was the adult ticket and child ticket for a zoo or something like that. Remember how we wrote two equations in standard form? We're basically doing that again. Well, most people did. Ilya is saying he doesn't remember it. But we're going to write standard form equations, and instead of solving by graphing, we're going to solve by substitution. But once we have the ability to solve by substitution and or elimination, we can do these things called mixture problems. I don't know if anybody remembers mixture problems from Algebra 1. I know it's painful to try to teach it to Algebra 1, so I'm going to hope that everybody in here will just have to brush the dust off and remember how to do this. Mr. M is mixing up an acid solution. By the way, that's me. He needs 256 milliliters of a 4% acid solution to help dispose of the evidence. If he has a 2.5% acid solution and a 6.5% acid solution, how much of each solution should he use in order to make the mixture that he needs to dodge the law? Like one chuckle. That stuff is funny, people. And it's based on a true story. I'm not going to tell you the crime or the story until we finish. Yes, I had to dodge the law. I made an acid solution.
Oh, was that with the cone?
I almost died.
Oh, yeah.
Mm-hmm.
Yeah. Can you tell me what was in the cone?
Yeah, it was a cone. Yeah. But I'm not telling you the whole story. I'm trying to do math. Okay.
Someone already told me this.
Well, someone ruined it for you then.
It was Nick Neville.
Well, you tell Nick, shame on him for ruining the punchline. Dumbledore dies. Did you know that? You see, it sucks when people tell you the end. Okay, so the hardest part about these kinds of things is going to be writing your equations. So let's write up our equations. There are two variables, as usual, because we're dealing with everything in two variables, right? X and Y. It doesn't matter which one you call X and which one you call Y. That's not important. All that matters is that you actually write it down. Because the third most missed question on my test was the short question that only had 4 options. It was the third most missed question. No. Was that the most missed and only 30% got it right? It was one of those two. The short question. It was A, B, C, D. And like 30% of my students got it right. I have people taking the test right now, so I can't say. I don't know. No. But I would say those of you that missed it It's because you didn't label your variables.
But was that the last question?
So they were shuffled up for everybody, so who knows which one it was for you. Let's say I'm going to let variable x stand for the 2.5% solution. And I'll let y be the 6.5% solution. There. What do we know? We know that I'm going to take an unknown amount of x, I'm going to mix it with an unknown amount of y, and once I'm finished mixing, I'll have exactly 256 milliliters. First equation's easy. There it is. This is when I taught Algebra 1, I called it the amounts equation. The second equation isn't the amounts. The second equation deals with the percents. It's the percents equation, or the rates equation. And I chose to say the word rate for a reason, because I taught you guys in some previous lessons that whenever you're doing these kinds of word problems, anytime you see a rate, it always belongs in the same place in our equation. Ilya?
Where would you put the 4%?
Oh, I thought he was about to tell me the answer. You tell me. Where do we put our rates when we write our equations? Where do rates belong in any equation? Well, where do we find slope?
Next to x.
It's in front of a variable. All rates belong in front of variables. Now, Ilya asked me where the 4% goes. Well, 4% is the rate of what part of this equation? The 256. So x has the 2.5 rate. Y has the 6.5 rate. I understand it's not a slope, but that's how we treat them. Oh, whoa. Y, not x. And then the 4% belongs to the 256. And I don't like that dot now that I wrote it, so I'll write it as parentheses. It doesn't matter. It means the same thing. There's our two equations. Is that easy? And we can choose to use substitution or elimination, completely up to you, but since we're doing substitution right now, I say we do substitution right now. And yes?
Why'd you put the 2.5 instead?
Because I've said that x is the 2.5 solution. So the letter x stands for an amount of liquid. So I need a certain amount of this liquid and a certain amount of this liquid to get this amount of liquid.
So you're like multiplying it by itself?
No, I'm not multiplying by itself. This is representing an unknown amount of this liquid. So I'm labeling it as the 2.5% liquid. But x is literally an amount. How much x do I need? I don't know how much x I need. I don't know how much y I need, but I know x and y together better give me 256. But I know the quote-unquote rate of x is 2.5 and the quote-unquote rate of y is 6.5, and the rate of the 256 will be 4. Okay? I'm going to go ahead and get y by itself, just because why not? I'll just subtract an x from both sides right here. And what that's going to allow me to do is, instead of writing this y, I'm going to be able to write what it equals. It's going to tell me that y is 256 minus x. And I could take that expression and throw it right there. So 2.5x plus 6.5, and then what y equals 1024, because that's what 4 times 256 is. Now we just distribute like we did before. So we distribute the 6.5. I'm going to get 2.5x plus, is it 1660? 1660?
I think it's 160.
What is it? 1664? Okay, I'm doing it from memory from a while ago. Yeah, 1664. Minus 6.5x equals 1024. And these right here are like terms. 2.5 minus 6.5 is going to give me negative 4. So I have negative 4x plus 1664 is the 1024. Subtract and divide. So negative 4x equals whatever that is. Negative 640. And then divide by negative 4 to get 60. X equals 160 milliliters of 2.5%. Again, we're going to want to label these because on the word problems on the tests, if you don't have them labeled, you'll be getting down to that 50-50 chance at the end again. And we don't want you to have to guess. Okay? So if you know that x is 160, you use it right there to solve for y. And y is 256 minus what we got for x, because that's what it says, minus 160. Y is 96 milliliters of the 6.5% solution. And there it is. Whoa. That was a loud nerd.